Alright, this is our first revision tutorial on pressure, and if you would know that pressure over here is given by force divided by area. So where the standard definition of pressure, this is force given in newtons and it's divided by area. Now remember that when you are talking about pressure, and one thing is that the unit of pressure is pascals. Okay, the SI unit of pressure is pascals, but what pascals is actually equal to is Newton per meter square. So always remember in your problem, when you have area in suppose centimeters or millimeters square, you have to always convert it to meter square, otherwise you cannot use pascals. Pascals is only applicable when you have Newton per meter square. So for example, if I give you an example where you have a force of say 2 newtons on an area of, let's just say, 2 by 2 centimeters. So basically you have a square where each side is 2 centimeters, right? Okay, now if I ask you to find what's the pressure on that area, basically you can draw the pressure like this with the force of 2 newtons acting. I can easily say that the area is 4 centimeters square. Now remember, this is in centimeters square. You have to convert it to meter square. So what is 4 centimeters square in meter square? Basically is 4 divided by 100 times 100, whatever that is, meter square, and this is the force. So remember, whenever you're going to do problems related to pressure, always convert whatever you have to meter square. That's for sure. Okay, so now if I just clear off everything and now start to talk about, let's say, so suppose now we are going to discuss pressure in a fluid, right? So pretty simple is that, suppose I'm trying to do my best diagram possible of a swimming pool. So suppose here's a swimming pool and here's you standing at the bottom of the swimming pool. I know that's not realistic, but let's say you're 10 meters below the swimming pool. Now I'm going to ask you, what is the pressure you experience at the bottom of the swimming pool at the depth of 10 meters? So the formula, the pressure in a fluid, the formula is given by pressure is equal to H times rho times G. Now if you look carefully, H is the height or the depth. So in our case over here it's 10 meters, right? Pretty simple. Rho is the density of the fluid. So in water, in case of water, is basically 1 kilogram per meter cube in terms of meter cube, and G is the acceleration due to gravity. So this is 10 meters per second. Sorry, this one is wrong. The density of water is 1000 kilogram per meter cube. So the pressure which is experienced by me is quite large because I'm underneath water. So it's 10 times 1000 times 10. So this works out to be 10 to the power of 1, 2, 3, 4, 5, 10 to the power 5 pascals underneath water. So under water, under 10 meters of water, you really experience a lot of pressure. So this is pretty much simple formula for H rho G and of pressure at a certain depth in a fluid. We are going to discuss more about transmission of pressure in a fluid and like liquid columns, and also about manometers in the next video. Thanks.